Welcome back. So last class, we worked on what is a function, a specific type of relation. We're going to get a little more formality on that now. If we want to decide if something is a function, what we're trying to decide is, does this relation give a single reliable answer every time I put in an x value? So for example, let's say that you know when you put in 1 hour of time on a homework assignment in pre-calculus, that you're going to get it all correct. Let's say that that's a rule. If you put in 1 hour of time, you always get it all correct, which means you'll get a 5 out of 5 on the homework. A function means that when you put in that 1 hour of time, you get a reliable output like a 5 out of 5. If when you put in 1 hour of time, you sometimes got a 5 and you sometimes got a 1, it would feel unreliable. That wouldn't feel like something that you'd want to do a lot because you never know what you're going to get. In the same way, what you need with a function is each element of the domain, the input, is paired with exactly one element of the range. And so what that looks like with a table of values is that every time there's an x value, there's exactly one y value. Since all the x's are different, this table doesn't suggest this has any problems. This is all good. But here, what do we see coming out of the -9 value? Two possible answers. If you put in a -9, you might get -2, you might get 5. Therefore, this is not a function. This is a function, yes. Here, I see a y value repeating. I see that if I put in an x of -7 or an x of -5, thank you, I get a y value that's consistent. But that's okay. That's like a parabola. What I'm looking for is, does an x value show up twice, giving me different y values? In this case, not a problem. This is also a function. We can look at graphs and make determinations as well. The way we do that is we do a vertical line test and effectively put a ruler down and see if as we slide that ruler along, does it ever make the function get crossed twice? In this case, it only crosses once at every point. So yes, this is a function. In this case, for example, here, when I plug in an x value of 2, I don't know which y value I'm getting. I've got two possible answers. Therefore, it's unreliable. This is not a function. Any questions on how to determine if something is a function? I'll leave number 18 for you to do yourselves. The rest of this packet is about working with functions, specifically looking at features of functions and what that does for us. We're not going to cover as much today about what it does for us. We're just going to talk about the features, how to look at it, how to talk about it. So the first thing we're going to talk about is whether the function is increasing or decreasing or constant. You can also think about this as slope. This slope is positive, which means that as we move forward in time, let's say, pretend the x-axis is time, whatever value I started with, later in time, my next y value is bigger. This is an increasing region of the graph. Therefore, I want to express that as increasing on the interval using interval notation. So here I'm looking at arrow. So -infinity is my furthest left. It stops at -1. And I'm going to say it increases on the interval from that -infinity to that -1. Now, a fine point is that a function isn't increasing or decreasing at a point. It's increasing or decreasing from one point to the next. So therefore, always with increasing functions, we'll have the soft brackets. Just like with decreasing functions, we'll have the soft brackets. Even though there's a dot there, we're not saying that it increases within that dot. It's static at that point. Subtle piece. It's constant from -1. It stays the same y value all the way until 1, 2, 3, 4. And then it begins to decrease. From 4, it decreases forever on to infinity. Would you guys please do number 5 yourself now? See if you can find the increasing interval and the decreasing interval and write it as interval notation. Go. Do as many as you want. They're all homework.
Mr. Erlen,
Yeah.
which one's the increasing interval?
Increasing is when the slope is positive. So for instance, going from something lower to something higher. Now, the most likely confusion here is mixing up X and Y. What do we look at to decide whether the function is increasing or decreasing? X values or Y values?
What?
Y values. If the Y values are getting bigger, then as we go left to right, that tells us that it's increasing. If the Y values are getting smaller as we go left to right, then it's decreasing. If the Y values are staying the same, then it's constant. But when I talk about what interval that occurs in, I use the X values. I look at the Y values, but I answer with the X values. So for example, if this is like -5, 5 coordinate up here somewhere, and then when I go a little bit closer to 0, like -4, it's 4, I can see that the Y values are decreasing. So this is decreasing, but I'm going to include these points in my answer. So it decreases from -infinity to 1, 2, 3. And then it starts to increase. So from 3 to infinity, it increases. Check your answers against mine. How'd you do? 5, I got it right. I understand it. 3, I struggled. I sort of got it right, but I'm not confident I could do it next time. 1, I don't have it yet. Okay, hands down. Let's take a look over here. And let's think about it a slightly different way. Actually, let's move down to number 8. Start on the furthest left point. So we're going from -infinity. And then start moving in. Would you say as you move in, the Y values are getting smaller or larger? Smaller. They're getting smaller. So this is going to be decreasing until what point? Till what X value? 0. So I know that from -infinity to 0, I'm going to put in the decreasing category. Now I'm at 0. 0 travels until the point about 2.5 as an increasing, decreasing, or constant function. Increasing. It's getting bigger and bigger and bigger from 0 to about 2.5. So we'll call that increasing. At 2.5, it begins a ride this way. Is that increasing or decreasing? Decreasing. So I would take these pieces of information and say, okay, my increasing interval was 0 to 2.5. My decreasing interval had 2 of them, -infinity to 0, u, 2.5 to infinity. That says 2.5. Does that help a little bit? Okay, please try number 9 yourselves now. Go. Okay, can I get a volunteer to tell me the first part? Coming from negative infinity down to 1, 2, what is that, 3? -2. Is that increasing or decreasing? Decreasing. So I'm going to say negative infinity to -2 is decreasing. Okay, from -2 up to 0, what happens? Good. -2 to 0 is increasing. From 0 to 1, what happens? Decreasing. And union between those. And then from 1 onward, increasing. How does that feel? 5. I think I got this now. 3. My knowledge is increasing, but it's not there yet. 1. My knowledge is constantly 0. Good. Any clarifying questions? Okay. Flip the page, please. Another feature we're going to look at regarding functions becomes very important is this idea of continuity, continuous. And you might think about it as if I were to take an electrical outlet and plug this side into an electrical outlet and this side into something like a light bulb, is the path continuous? Would the electricity flow all the way through it? And if the answer is yes, that's considered continuous. A graph is said to be continuous if there are no breaks or holes. If there are breaks or holes in the graphs, it's considered to be discontinuous. This is a binary scenario. There's only 2 choices. Either it's continuous or it's discontinuous. Once you see that it's discontinuous, there are 3 types. One type is where you have this huge chasm, right? A vertical asymptote that breaks it, that doesn't cross over, doesn't connect them. This is called an infinite discontinuity. Another is where it's going along and hits some point. Usually one of them is a hole. And then it jumps to another spot and continues on. This is called a jump discontinuity. And the other is a hole. And a hole is a specific restriction on the x value that if you removed that restriction, the function would be continuous. It's otherwise continuous. This is called a removable discontinuity. So for example, will this conduct electricity or not? No. Therefore, is this continuous or discontinuous? Good. So we'd say discontinuous. And then we have to classify it. This discontinuity is what kind? Jump. Good. What about number 2? Continuous or discontinuous? Continuous. And since it's continuous, we don't have to worry about what type of discontinuity because it doesn't have one. What about number 3? Take a moment, talk to your neighbor, see what you come up with. Go. I heard a bunch of people say it. This is discontinuous and what type? Infinite. Good. Okay. I'm going to leave 4, 5, and 6 for you to do as part of your homework. The next piece is talking about end behavior. And actually, I'm going to use a different set of examples before we fill this in. You guys have worked enough with polynomials to have figured this out. Y equals x looks like that. Y equals x to the third looks something like this. Oops, sorry. It looks something like that. Y equals x to the fifth, blah, 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 whatever else is in there. A polynomial in the fifth degree looks something like that. When I do an exponent like 2, I get a parabola. When I do an exponent of 4, I get a W. What do you notice is common about x squared and x to the fourth? Yeah. They end up going the same direction. That's exactly what we're talking about here. Notice she used the word end because we're talking about the end behavior. And so what we would say is, well, there's two ends here. There's the beginning end and the end end. So we'd say, as x approaches negative infinity, in other words, we're looking at this left-hand side, f of x, the y value, approaches positive infinity. When we go to the left here, it goes up. As x approaches positive infinity, f of x approaches what? Also positive infinity. What about x to the third? So first, as x approaches negative infinity, f of x approaches what? Would you say that the y value as I move over here towards x value of negative infinity, is the y value positive infinity or negative infinity? Negative. Now let's go back and look here. As x gets bigger and bigger and bigger, so as x approaches positive infinity, what happens to the y value? What does it approach? Positive infinity. What if I gave you a function that looked like that? As x approaches negative infinity, f of x approaches what? Good, positive infinity. And as x approaches positive infinity, f of x approaches what? Negative infinity. Okay, good. That's what this piece is all about. So looking at this on the left here, as x approaches positive infinity, over here, what does f of x approach? Good, negative infinity. And as x approaches negative infinity, I would do this the other way normally. What does f of x approach? Positive infinity. It's also possible that they could approach a single number, which a lot of these do. In fact, all of these do. So here, as x approaches negative infinity, f of x approaches what? I'd say -3. Is it -3.2? I don't know. I don't know exactly what it is, but let's say -3. As x approaches positive infinity, f of x approaches what? Also -3. I don't think it's negative infinity. I don't think it's going down forever. I think it's actually bottoming out there. So do the best you can with these. Make your best assumptions. Okay. Next page. We're going to be talking about implicit versus explicit equations. if I were to, sorry, explicit equations solved for one variable. In other words, when I say like y equals 2x plus 1, or if I were to say like y is equal to square root of x minus 3, or if I were to say x equals 1 over y. In all of these cases, one side of my equation, often the left, is solved for a single variable. That's in explicit form. We're telling you exactly what that function is. When it's implicit, it's a little bit messed up. So it's not solved for a single variable. So an example for that would be something like in standard form, 2x plus y equals 5. That's not solved for a single variable. Or when we have something like a circle, like x minus 1 squared plus y minus 2 squared equals 5. It's not solved for a single variable. So the directions say, write each equation explicitly. So it's going to be solved for a single variable in terms of x. I think that's confusing the way it's phrased. What it means is on the right-hand side, you'll only have x's. So here, I'm going to solve this for y. So what would I do first? That's going to solve it for x. I want to solve it for y. And I'll show you how that means in terms of x in a moment. I'm going to subtract the x. So I get negative 4y equals negative x plus 20. And then I'll divide by the negative 4. And I'll get y is equal to 1/4 x minus 5. We've now solved explicitly for y, not as a number, not like y equals 7, but in terms of x. Whatever x is, I take 1/4 of it and subtract 5, and that's what y is. We'll come back to the second part where it asks if it's a function in just a moment. Let's take a look at number 3. If I want to solve for y, I get y equals. How do I know what to do first? Let me give you a little analogy on this. You guys know PEMDAS, right? Let's say that you are wrapping a present for your best friend. It's their birthday. Okay. And you've decided to give them a lollipop. Okay. So the first thing you do is you put that lollipop into a box. Then you close the box. Then you put wrapping paper on. Then you tie the bow. You guys agree? Now, this is what you do if you're evaluating. If you're given numbers in an equation, you plug them in and you have to follow PEMDAS in that order. But when you receive the present, someone's just given you this lovely present, what is the first thing you do? Well, after you thank them. Yeah, you untie the bow, right? So in other words, this was step 1, this was step 2, this was step 3, this was step 4. Now to unwrap it, your untie is the first thing. And then the second thing you do is you take the wrapping paper off. That's the second thing. And then instead of closing the box, you open the box. That's the third thing. And instead of putting the sucker in, you take it out. That's the fourth thing. So in other words, when we get the present, we not only do it in reverse order, but each step is backwards. It's the opposite. So if I want to take this, I'm not evaluating, I'm not putting values in for X and Y, I'm solving for Y. I'm going to look at this and say, I've got parentheses, I've got exponents, I don't have any multiplication, and I have addition, subtraction. So with PEMDAS, I would do the parentheses first and the addition, subtraction last. But because I'm unwrapping this present, I go backwards. So I'm going to undo the addition, subtraction first. What's the opposite of minus X? Plus X. Okay, now I'm up to my exponents. What's the opposite of squaring? Square root. So I'll square root both sides. And this is really important. When I introduce that square root function, when I reach out and pull out that tool, what do I have to include? Good. Plus or minus. And now I'm to my parentheses. These had been in parentheses, and so I'll resolve what's in there by subtracting again. Make sure that that -1 is outside of the square root symbol. How do you feel about unwrapping these equations to take them from implicit form to explicit form? 5, I can totally do this. This is my wheelhouse. 3, I can work that out. 1, that's going to be hard for me. Okay, please show me fingers, guys. Looking for feedback from everybody. Can you do this skill? 5, yes. 4, sort of. 3, pretty much. 2, less than pretty much. 1, not at all. Okay, good. Now, how do I decide whether these things are functions or not? What does a function have to have? Reliability. That when you put a value for X in, you always know there's exactly one Y value. If I put an X value in here, say I choose the number 4, 1/4 times 4 is 1, minus 5 is -4. Every time I put in a 4, I'm going to get back -4. Agreed? Nothing's going to change. If I keep putting 4 in there, it's going to keep giving me the same answer. So is that a function? Yeah, it's reliable. Look at number 3. Let's say that I put an X value in of 1. 3 plus 1 is 4. Square root of 4 is 2. So now I've got Y is equal to plus or minus 2 minus 1. It's possible I could take it as plus 2 minus 1 and get an answer of 1. In other words, the answer 1 comma 1 would be a solution. It's also possible I could take it as a minus 2. So now it's -2 minus 1 is -3. Because when I plug in a single X value, I have 2 possible Y values due to the plus or minus. Is this a function? It's not. So for our purposes today, that's what you're looking for, is when you see like a plus or minus. It's when the Y value was squared and you solve it by square rooting. Any questions on that? Try number 5 here, just to make sure you guys are getting it. Please take a moment to do number 5. Change it from implicit to explicit and determine if it's a function. Go. Okay. You've offered some good questions and people have caught some things that catch people. What's my first step to turn this into an explicit form? Minus X. Good. So now I've got a negative y plus 1 equals 8 minus x. Let's get rid of this first. This is being multiplied by -1. So what do I do to clear that? Divide by -1 or multiply by -1. Both will work. Either way, that's going to give me y plus 1 inside the square root equals -8 plus x. I'm going to write that differently. How can I write that in a way that makes more sense? X minus 8. Good. That little trick is important in pre-calculus. This idea that if I take 8 minus x and I distribute a negative across it, it becomes x minus 8. They trade places. File that in your brain. That's going to come up. Okay. Second part, I want to get rid of a square root. What gets rid of a square root? How do you undo square root? Squaring. Good. So that's going to turn this side into just a y plus 1. And this side, we can leave it as x minus 8 squared. If you wanted to FOIL it out, you'd get x squared minus 16x plus 64. Make sure you don't forget about the FOILing it out. And then lastly, we'll bring in this other piece, -1. That's my explicit form because I've solved it for y. Is this a function? Yeah, no matter what I put in for x, when I square it, it's going to be the same number. It's not like it's giving me a plus or minus. So yes, this is a function. How we feeling? 5, I have this bull by the horns. 3, I'm not going to stay on 8 seconds, but I can ride this bull. 1, I feel trampled. Okay. All right. There's another piece I want to present. Algebraically, this messes with people. Please do number 6 now. Got a little twist to it. Okay, I think we've discovered what makes this one hard, right? So I'm going to give you another example here, show you how I'd solve it, and see if this helps you, gets you a nudge. This one says xy plus y equals 8 minus x. I want to solve for y. Should I start by subtracting xy? No, because that's going to put a y over here. I want all my y's over here. Ollie, you got a suggestion? Is that a hand up? No, okay. Yeah. Is that a hand up? No, behind you. No? Okay. So do you agree that there's a y here and a y here? That's our problem. Think back to factoring. Greatest common factors. Can I factor this out? Isn't there a y in both of those? And now if I want to solve for y, what do? It's being multiplied by x plus 1. So I divide by x plus 1. So that would be the solution there. See if you can apply that same logic to the problem I just asked you to do. We're not dividing by y. We're factoring y out.
Maybe we got the moving but we need to get rid of the x.
If you finish this, you can move on to another one.
But there's still x. No, wait. Yeah, because that's we're all doing it.
But he's doing over something. No, it's the same logic. So when you factor out the y, that's why.
Wait, how did we? Wait. Oh, let me check. It's like in this restaurant.
Is it like, so like,
Okay, wait, I like it. It's for now. The one, so that's all. I can't. I get it. I was the treasurer in a club last year, and I don't even actually know. I actually never had to study treasury because we never like got any like funding. I also like, and I also. No, like never run and see what they're I don't even know. I talk about because.
Yeah. Oh, yeah.
I don't even think that would really get into. That all applies to that. I know, I guess. Wait, it was right.
Okay, that was actually kind of cool. I saw a bunch of actual light bulbs go off over your head. Step one, move the one. Since there's a y in both of these terms, it's a common term. Therefore, I can factor it out, leaving x minus 5. Remember how the other day we did some algebra practice with factoring? This is the kind of stuff you got to know. Factoring is really important. Now that you got y times something equals 2x plus 1, how do you undo that? Divide. So we divide both sides by x minus 5. So we get y is equal to 2x plus 1 over x minus 5. Now that's a complicated looking expression. Is it a function? It is, because unless we see like a plus or minus or something where there could be two answers, we don't have to worry about it. We say, yep, that's a function. Okay. One more concept with a slight challenge in it. To begin with, this should be really familiar. Function notation. If I write like y is equal to 2x plus 1, this is written in a traditional format. If I want to change it into function notation, all I do is I change the y to f of x. And that's read as f of x. You guys remember that, right? What are the benefits of using f of x rather than y? Why would we ever write it in function notation? One benefit is that if you have two equations like y equals 2x plus 1 and y equals 3x minus 6, it's hard to point out which equation you're talking about without saying the whole equation. If you were to say f of x equals 2x plus 1, you could say like g of x equals 3x minus 6. And now you could use those different names. Say, well, take g of x and square it. And then subtract f of x. You can name them better. The second thing that's helpful is let's say that you're trying to figure out ordered pairs. And you want to put a value of 2 in for x. You could put that in, you get 0. Which function did I put it into? Because suddenly I've got this coordinate. I don't know what it means. But over here, I could say that f of 2 is equal to 5 and g of 2 is equal to 0. And that conveys a whole lot more information. Tells me that in the g function, when I plug in a 2 for x, I get a y value of 0. When I take the f function and plug a 2 in for x, it gives me a y value of 5. So what we're going to ask you to do is evaluate these functions, which simply means you take the original function. If f of x is equal to x squared minus 6x plus 23, then f of blank is equal to blank squared minus 6 blank plus 23. Can we all agree with that? That means, if I write that again, just for clarity in the notes, I can plug in, instead of x, I'm going to plug in -5. And that shows me that -5 squared is 25. -6 times -5 is plus 30. Oh, I did get 23. Plus 23. So 48, 78. And what is 78? Oh, well, that's the value of the f function when I plug in an x of -5. Five, finally some stuff we've done a bunch before in advanced algebra. This is old hat. 3. Okay, that kind of makes sense. We did a little bit of this, but I got to practice it a little bit. 1, we never did that before. Okay. Is it any different when it says h of 9 for an h of x function? No, same idea exactly. What's the added little twist? Come down here to number 17. I recommend when you do these things, you start with what I started last time. H of blank equals blank squared minus blank minus 1. And then you say, okay, if I'm going to plug in 2a plus 7, then I plug in 2a plus 7 here, and I plug in 2a plus 7 here. Most people who do these things and make mistakes end up like multiplying this by 2a plus 7 instead of replacing the x with 2a plus 7. So I recommend you start with those open holes. That makes it easier. And we've still got this idea of how do we FOIL that out? 2a plus 7 squared is the same as 2a plus 7 times 2a plus 7. So I'm going to get 4a squared plus 14a plus another 14a is 28a plus 49. So 4a squared plus 28a plus 49. I have to distribute this negative through. So minus 2a minus 7 minus 1. And then combine like terms. (28a minus 2 is going to be 26a. 49 minus 8 is plus 41. All right, this is homework number 4. Please finish this up tonight. Take pictures, turn it into a PDF, submit it in Canvas. If you haven't yet had success with submitting Canvas and you need help with that, come on over. I'm happy to show you. Please finish this up along with 2 and 3 if you haven't already.